And now let's say we can call it a day. We are quite satisfied with what we have achieved from now for now, and we can export what we have constructed here so that the results can be used in the simulation. But first, to make it safe, I will save. Okay, I will save the project. Okay, click project and then, yeah, so it's being saved automatically, I think. Or you can also save as. Okay, so the next thing that we will do is export. We have several types of files that we can obtain from by exporting. So we will try 4 methods to export all the operation that we have done uh, now. Okay. Okay, so now we will export. We have several methods to export. The first one is export properties, and the second one is export comp VD and temp VD. You will know it better later. And then export as black oil variant or export using regions. Okay, you will know that after I show you. Okay, now from here we can, for example, this one, export to file. Okay, let's check this one first. Okay, so again, I will show you so that you can know it better. This one, export to file. Now you see props blend here in this case. Okay, yeah, again, I have blended the fluids. Okay, the story is like this. I have data, laboratory data, and I create model that has been matched with the data, and then the model or the matching model, the match model is too heavy, so I just do lumping to reduce simulation time. But after blending, after lumping, I blend the fluid to construct only one blend component. So now I import the properties here, props blend, the name of the file, and the file type is .inc or include. So click save. Okay. Let's wait for a while. Okay, it has been saved. So I go to my folder, go to the project. Now you see I have the TNAV project and props blend, the properties file. Let's go inside, double click. Okay, now you see all these keywords and these component names from nitrogen down to C12 plus. This is the water component names, critical pressure, critical temperature, critical molar volume for viscosity correlation, critical molar volume for each component. And then this one, molecular weight, binary interaction coefficients, eccentric factor, all right, boiling points, all right, omega A, omega B, component paracores, volume shift parameters, and then this coefficient, equation of state, Peng-Robinson, the reservoir temperature 100. Okay, so that's the first method to export. So later on, we can use this file to be included in our reservoir simulation. Okay, so that's the first method. Now we will try the second method.